What if I told you that there's a single number, just one percentage, that claims to explain how two things are connected? Like how the hours you cram for a test relate to your final score, or how much a big marketing push actually impacts sales. Well, that powerful little number is called R squared.
And let's be real, this is a question we have all asked ourselves at some point. It just feels like it should be true, right? But how can we know for sure? Just how strong is that connection, really? This is the exact kind of problem where R squared is supposed to shine.
So to get to the bottom of this, we're going to look at some real data. A stats instructor actually tracked 12 of their students. They looked at the number of optional homework problems they did, and then checked their final course grade. This is going to be our case study. Okay, before we jump into any fancy statistics or calculations, the best first step is always the simplest one. Just look at the data. Let's plot it out and see if our eyes can pick up on any kind of pattern.
And boom, the second we plot each student as a little dot on a graph, a pattern just jumps right out at you. See that? The points kind of form a rough line that slopes upwards. As you move to the right, which means more homework problems, the points also tend to be higher up, which means better grades. This is a big clue that we have what's called a positive relationship.
Now, to make some real sense of this cloud of points, we use a tool called linear regression. All that is, really, is just drawing the one single straight line that best slices through the center of all that data. You'll often hear it called the line of best fit. But here's the cool part. This line is way more than just a summary. It's actually a predictive model. We can now pick any number of homework problems on the bottom, trace our finger up to that line, and see what grade our model predicts a student would probably get. It's like a little fortune-telling machine.
Okay, so we've built a model. We have our prediction machine. But that leads to the million-dollar question. Is it any good? I mean, how well does our line actually represent what happened in the real world? We need a score.
And that score is R squared. Now, it has a very fancy formal name, the coefficient of determination, but honestly, pretty much everyone just calls it R squared. And what it tells us specifically is the percentage of the differences we see in student grades that can be explained by the differences in how much homework they did. So for our student data, what's the R squared value? Drum roll, please. It's 78.4%.
Okay, but what does that number actually mean in plain English? Here's the key takeaway. It tells us that almost 80% of the reason why some students got A's and others got C's can be accounted for by how many homework problems they turned in. The other 22%, well, that's due to other stuff.
And this really shows the general rule of thumb perfectly. The higher the R squared, the closer you get to 100%, the better the fit. It means your model is doing a great job explaining things. A lower value means your chosen factor, in our case homework, it just doesn't really explain the final outcome all that well.
Now, an R squared of 78.4%, that feels pretty powerful, doesn't it? It feels like we've basically proven that doing homework causes good grades. But, and this is a huge but, this is exactly where we have to be so careful. We're about to run smack into the biggest, most common trap in all of statistics. You've probably heard this before, but let's say it together. Correlation does not imply causation. Just because two things move together, even if it's super predictable, that does not mean that one is making the other happen. R squared is all about correlation, not causation. Here's the perfect way to get your head around this. Think about ice cream sales and sunscreen sales. They are highly correlated. You'd get a huge R squared value. But does buying a scoop of ice cream make you want to go buy sunscreen? Of course not. There's a hidden factor, the hot, sunny weather, that causes both to go up. That's correlation. Causation is totally different. That's when we have strong evidence that one thing directly leads to another, like the established link between smoking and lung cancer. So this brings us to what might be the most critical part of this whole explainer. R squared is a fantastic tool for sure, but it's understanding what it can't tell you that really separates someone who knows what they're doing from someone just throwing numbers around. So think about it. R squared tells us absolutely nothing about whether homework caused the grade change. It can't tell us about other important factors, like maybe the students who did more homework also just happened to have better study habits or never missed a class. It doesn't even tell us if a straight line was the right kind of model to use in the first place, or if we even have enough data to be confident, or if one or two weird students are throwing the whole thing off. It's just one piece of a much bigger puzzle. So the big takeaway is this.
R-squared is an amazing measure of how well your model explains the data you've already collected. But before you go and use that model to make big bets on the future, you have to stop and remember everything it doesn't tell you. Always remember, R-squared is a great place to start your analysis, but it should never, ever be the end.